Okay, so yesterday we learned about creating a class called player. Okay, so we created 4 instance variables here. These are the actual different types of terminologies that are commonly used in the OOP. You will hear this all the time. Sometimes it's just called properties. Okay, and then we learn about constructors, a special function that is used to create the object itself. And you can have multiple constructors because when you create objects like we did over here, you can set up data right away, like the name, the type, and all the attributes right away, or you can create one without them being set at all, and then you can set them manually after that. Okay, so that's why you provide different types of constructors to give that flexibility to other developers. Okay, and then we learn about 2 functions very similar to the constructor function up here. One thing you notice is that the constructors do not have a return type. So you see the word public followed by the name of that function, which is in this case is the same name as the class. Okay, it's just a rule. And C# and Java is the same name. This is not true if you are, later if you see Python or JavaScript or PHP, they're different. Okay, but C#, C++, I think, and Java, they all have the same name as the class name. Okay, so they do not have a return type. So you can see just the word public, and then the name of the class or function, and then the parentheses plus any parameters you can pass to them. The functions, however, as we learned before, always have a return type. Either return nothing, void, or return something. You cannot have a function that looks like that. If it is like that, it's expect that to be a constructor. Okay, so just that's just the rule. And I showed you how you can have 2 functions that have the same name and have different signature. Okay, if I put here instead of void, if I put like return a type int, and let's just say in here I put return 1, right? You can see that I didn't show this yesterday, but it's completely valid too, right? It doesn't have to have the same return type. It can be different type. This one is the same name. This one takes no parameter. This one takes 1 parameter. If you take the parameter out, you see that it has the same problem because now I'm duplicating my functions. So the return type doesn't really matter when you are overloading functions. I should put here another message, say method overload. Okay, so you hear the term overload. I am creating the same function that has different signature. Okay, and then the return type, it doesn't matter. Alright, so I'll put back to void. So we learned that, and then now I want to cover the attributes up here. So again, notice these are all private. I showed you yesterday that since you set these to private, these data variables can only be accessed within this class called player, so only in this file, right? You cannot access it from anywhere else from other classes. So you can see you can use the name here. I can use the type, the HP score anywhere in my code in the same file, the same class here, no problem. It doesn't matter what this modifier is, whether it's public, private, protected, or what it is. Okay? But it's important when you are dealing with 2 classes, this class called player and this class called program. It's a different class, and you're trying to access the data in the player class through an object. So we showed yesterday that if I try to access the name through the P1 object, you see that it's not visible. The only one that's visible is the run function that we create, right? So these up here are just default functions that always come with objects, and we didn't create them like the equals, get hash code, get type, and toString. These are provided by C# by default and the object class. Okay, but the one that we create is called run. That's available because we set it to public, right? If I go back and if I change it to private, then yeah, it's going to be gone. If I change to private, if I change both of them to private, so the same rules apply. Now it's private only to the class here. So over here, it's not going to be visible anymore, right? It's no longer here. So you can't use it anymore. You can't access it. So in this case, all these P1, 2, and 3 objects have no access to anything in that class at all. Okay? All you can do is just instantiate these objects, and then that's it. You can print them out using the print, but there's nothing can be done because you cannot use any of these functions at all. Okay, so again, that's privacy. And sometimes you want to have a special function that maybe you don't want to expose to other classes to use. So you can have a special function here to calculate some data that only pertain to this class and other classes don't need to know, right? So that is why we have encapsulation and we have this thing called a black box. Okay, so like the speed here, for example, I can pass speed to this run class, and then you don't know what's going on inside here. I could have another function here. I could set to private and say void and calculate. No, it's just calc speed or something, and I pass the int speed to it too, and then I'll return. Maybe I'll do an integer and then return the speed, whatever it is. Return speed times, I don't know, any number you want. And then, so from within this class, when I create run with the speed number, I can return like int n equals to calc speed. I pass speed to it. So, right? So you see the code, so you know what's going on because you have access to it. But outsiders don't know what's going on. All they know is I pass some data to the run function. I put some numbers in here, and all I'm getting back is some numbers, right? They have no idea what's going on. They don't know how it's calculated. Even if they see this function, they have no idea what calc speed does because it's set to private. Okay, so that's encapsulation. And there are times when you write your code, you want to do it this way because you don't need to expose this to the outside world. Okay, so privacy, private, makes it really important. Okay, so now how do you access these names and type and HP and score? Because right now I set them all to private, and when you print them out, there is no way to print them out, right? So if I want to print out like a console.write, I want to write out the P1's name. I can't. There's no way to get it. Right? It's not available. So what you do, since they're private, then you create some special functions called setters and getters. And I'll put it right here. These are called setters. And I'll do the setters first. Setters means you can set the data. If I happen to call this constructor, as you can see, when I do that for my P1, right, there's no data set to that player, P1. So how do you set the name and the type and all those stuff later on? Well, the only way to do that is if you provide some setter functions. Okay, so these will be special functions that you make them public, and since you are setting data, therefore you're not returning anything. So I'm just going to type void, and in this case, I would say set, use the function set name, and then here you would need to pass in a string of type name. It looks very similar to this constructor here, right? I'm passing only the name. Actually, it looks just like this one here. But it goes through a function called set name. And here then, it's going to say this name is equal to the name I pass to it. Okay, so I'll make that public. And so you can see I can set this name up here indirectly through a function called setName. Okay, so this is called a setter. So over here then I can now say p1 dot, you see that it's available here, setName. It's a function. You pass in the name called Susie, right? So now the p1 now has a name. And again, how do you print it out? Because we didn't have a function to print either. So I cannot access the p1.name directly, but I can change it through a function called setName. So now as a programmer, you have control of what data should be set to this name variable. Okay? And the reason why we set it to private is because you can control the data passed to it. If you don't control it, if you make it private, public, right? If I do, or even like for example HP, if I make that public, you're going to run into several issues. One of them is, let's just say if I go back here, if I want to change p1's dot HP, as you can see it's available here, HP. If I change it to 100, that's fine. But what if a user, someone change it to a negative 100, right? See, it takes the number, and there's no way for you to validate that. You can't check it because when you share your class to other people to use it, you can't control it. Okay, so if the programmer who uses this give you a really weird number, then that program is going to be incorrect. Okay, so you don't want to do that. So by using a function, you can control. You can say, okay, I want to check the number, make sure it's a positive number. It cannot be a negative number, right? If it is, then you want to throw an error saying you can't try again or just default to 0 or something, right? So you have control. Another reason why is, let's just say in my code here. So let's just say if I change that here, and then P2 also has HP 120, I don't know, just any number. P3 has HP. They have access to those numbers, right? Okay, so I can have access to those numbers, those HP variables, and change the numbers. The problem becomes when, let's just say that you are the coder, you share this code. You can see it's a library you can pass to other users to use it. And suddenly you want to change this variable to something else. You want to change it to maybe, I like it capitalized HP better than lowercase. Well, now you have a problem because these are no longer valid. Right? So everywhere else in this code here, where I had a lowercase HP, I must change them all to match the variable called HP in uppercase. So this is just an example. I've shown you 3 of them. There could be hundreds of them or thousands of them, right? So you can see the issue there. That's why we don't want people to access your variable in here. And instead of accessing this variable publicly, we set to private. And then what you do is you use setters and getters. Okay, so here I can do again, public void set. And its convention, use the word set followed by the name of the variable. So HP, right? So set HP, set name, and then you pass what to the HP. Is an integer, right? So HP, and then you say this HP equals to the HP it's passed to it. So these are setters. And you will do the same for all the other variables. And then how do you get those data back? These are called getters. Okay. Another name used for setters is called, it's called mutators. Because they mutate the data, right? They change the data based on what they pass to it. And then the getters are called the accessors. So you access data. Basically, that's all it is. So when you get data, you would, again, make the public function. I'm returning something, right? I'm getting something back, so I'm returning something. I want to get the name. What the name type is a string. So instead of void, I need to return a string. And the function is get the name. Get name. I'm not passing any data to it. I'm just basically retrieve the name. So when you're returning string, you just put here return function, return statement, return the this.name. Okay, so now I can get the name back, and same thing with the HP. So get HP, and then here just return this.hp. Okay, so now I can get this data back through these functions called get name, get HP, and get scores, and so on. So over here, as you can see, this is no longer valid. But I can pass to a function called set HP. It's a function, so you pass in through this parameter. As you can see, it takes the negative number, right? But now you have control. I didn't do it, but you can set over here in your code saying when you set the HPs, it must be positive. So you can say if HP is less than 0, then you just set this HP to maybe a default of 100, right? Else, and then you set the HP to the one that's passed to it, so that you will never have a negative number. You control that in your code, so you have more control. Whereas before, I couldn't do it, right? You have no control of that, and your program will be really weird. Okay, so I set my HP here, and so on. So now I can print get the name. It's a function, and then I can also do console. It's not very nice here. Right line in the P1 dot get HP. So it should be set to 100 because I passed a negative number, and it's going to set to a positive number. So hopefully when I run this, there's no error, and we will see. So you see here that the name is set to Susie, and the HP has been set to a positive 100, right? Because I passed an invalid number. Okay, so you have control of your code. All right, so now I can change this to anything I want. I can go back and say I want this to be called HP. I like that better. Then, well, you're still going to change down here anyway, but now you compare that to like 1,000 or 100 code lines. Here I only do a couple of them. So just maybe 3 places or 4 places. I'm done, right? And that's it. So over here, your program has no problem because usually you don't change the function. If you do that, go back to the same issue as before. Okay, if you do that, then you want to make sure that they know the function has been changed. Okay, so when I remove this back to the lowercase. So these are called setters and getters. They always go, they're always created when you create variables or attributes, when you set them and when you get the data back. As you can see, I have to have like a get name, get HP, get score, get whatever it is. I also should have the capability to set them as well. Okay, it always follows this convention here. This one here, and this one I'm checking that data, but you know, you don't have to do this, but usually you can. And so normally a programmer, you would validate outside here before you pass the number to it, right? So you don't want to do that here. I'm just showing that how you can validate data. Sometimes you have to do that, but not always. So before you put a number, usually you would validate first before you pass to the HP. Okay, so they have the same, as you can see, same pattern. get name, set name, get HP, and so on. And this is so very common. If you want, let's just say if you want the name or the HP to be read only, because right now we provide read and write, right? They can write to it and they can read from it. So if you want to do a read only, then don't provide the write. Don't provide the setters. So they cannot assign data. They can only retrieve the data, right? So you can set these numbers in a different way. From your class, you do something else. Or you can say, I don't want to give the read. They cannot read it. They can only write to it. So again, in that case, don't provide the getter functions. Okay, so that's what again gives you that flexibility, the read and write options. If you provide both, then yeah, they can read and write to your data. Okay, so this is the same way as you would see in Java. You need to have a getter and setter, exactly like this. The code will be very similar, if not the same. I think exactly the same as you see here. So if I have 10 variables, I'm going to have 10 getters and maybe 10 setters to go with it. If I'm allowing other classes or other people to set and get data. Okay, that's the worst case. So if I have 20 of them, I'm going to have 40 functions, right? And so in addition to all my variables here. Okay, so what C# does differently is the following. I'll keep the name and the HP as is, but the score in the type, for example. So C# provides this function, this special feature. So instead of doing what I did earlier with the HP and the name, C# says you could just do this. So I'm going to rewrite the score here. I'm going to make it public. Okay. Spell it. And I'm going to say the score is an integer type. And then I want to use the uppercase for the score. If you look at this, it's like the function, right? It's like the getter and setter. Down here, we say get functions and set name and set HP. So instead of the lowercase score, I'll use the uppercase score. And then I'll just basically do that. Let's see if I do this correctly. No, it's not correct. Let's see, get set. Yeah, so you can write it this way, and this, and let me turn this off now. I don't need that anymore. So this one will replace this and a setter for the get score, and a set score, and a getter for the get score. So you can eliminate two functions and a variable, and just call it this way. Okay? So let's call a getter and a setter. You just put the word get inside the curly braces here, followed by a semicolon, and a set, followed by a semicolon. And you put a parentheses, a curlies around that, and that's it. And this is pretty cool in C#. You cannot do this in Java. Okay, so that means I can now have score. I can use scores like a variable. So since I do this, then down here I have to say score. Okay, the uppercase score now. And then same thing wherever I use it in the code. Okay, so this is called a property. Technically, it's correctly called property in C#. Okay, so when I do that, then I don't need to do the setters and getters because they're already in here. and it's a shortcut. So now when I use it in my program over here, it's also very different. I don't call the function either. I'll just say p1 dot. You see that score is available here. It has a little wrench to it. Okay, so the wrench means it's a property. And if you click on it, it'll tell you it's a get and setter. So that means I can go and say score. I can set it to 50. Use it like a variable name. And then when I get it back, I can write it right line and then p1 dot score, like a variable name only. Okay? So now when I run it, I should get the same output as expected. I set to 50, I print it out, and I get 50 back. Okay? So that is one major difference between C# and Java. Java does not have this option. And this only works if you are not doing anything special with your data. Like if you do the HP like that, this will not work. Okay? Because you cannot validate. If you want to validate HP numbers, like you do here, then you don't want to use this option. Okay? This option does not check anything. It does not validate anything. So it's just same as the name, right? Just very plain. You set the name and you get the name. So therefore, if you're doing this way, if that's all you do, then really I don't need to have all that, and I can use the same method as I do up here, right? I could do the same thing. So say public string name and then get set. So now I'll use that. And then when I go back here and say, instead of set name, I'm just going to say p1 dot name equals Susie. So it looks like a variable name. Okay? And oh yeah, because I did not call the name variable here. So in this, doing this way, you just basically remove some line of code, makes your code shorter, and make this into a property. You can assign data to it, and you can print data to it. I mean, assign or change data as well. Read. So it's both read and write, just like a variable name, but it's a property. Okay, it's different than having a like a public int, you know, like points or something, right? Public points. If you go over here, if you type in p1 dot, you see that the points has a different icon. Okay, this is a different icon. It's a field. It says a field here. The name is not. It's a property. Okay, so they're being treated very differently, even though when you code it, it looks kind of the same. Points is 12, right? It works the same way, except they're not attributes, but it's a property instead. So C# gives you that little kind of a unique feature to it, saves you a lot of code, and so that you don't have to write get and set. It's already included in here. All right. Okay, what else I need to show you? Yeah, so with the classes, that's all you need to do here. So if you want to use this like in our game, for example, so the player is the actual player, and usually you keep track of, you know, items. I showed you this maybe very briefly. Items. So if you think about the names of your items, then you can use an array of items. So let's just say that you have your hero can only carry 5 items. That's the maximum that they can use. And if it's more than that, you have to dump one and trade with another one. If you play Diablo, or I'm sure other games very kind of similar, you have your bag. You can only store a certain number of items in the bag. If you found a better tool, a better weapon, well, you have to, toss one out, right? So you can replace it. That same thing, because you have a fixed array size of array. So so that means you have to write a function here, an array, to store that many data. So for example, I can say private string, and then we learn that the array is by using the name of, say, items, followed by like square brackets, right? And let's just say have we can set to just 3 items. So 1, 2, 3, 4, 5, right? Let's see. Let's just say new string of 5 items. Didn't like this way. Is it in front? Yeah, Java takes both ways. So Java, you can put the square brackets in front. I mean, here I attached to the string. Doesn't have to be. It could be on its own, or next to the data type. Usually, it's commonly do this way. But C# only takes that. In Java, you can put over here too if you want. That's why I tried it. It didn't work because it's not Java. So it's an array of 5 items, right? Starting from 0 through 4 index. So now, if you want to get all the items or set the items, then you have to write a function to set these items. Right now, by default, it's a string of 5 items. I mean, each slot is empty. So again, when you set items, you have to write your own setters and getters. So we set items, go down here, and then you want to have something like public void on set item. Then I need to know what item slot I need to set. So it will be this dot items of a particular index. I put the index equals to a particular item, right? So that means your set item function needs to have 2 parameters. One is the index position, one is the actual item name. So that means I need to have an integer for the index position and then a string for the item. Okay? So I can set it. So when I go over here, my player 1, let's just say I found a very nice sort of something. I can say p1.setItem. I'm going to pass into the first slot. The item is called a a sword. Okay, so now the first slot of my item has the sword in it. Right? And later on, if you find another one, then you can go and then, okay, I found another one in my next slot too. I'll put here a a hammer or something, right? Until you max out. So you have to track what the max size is. If you don't know, you need to get the size of this item. And how do you know that? Well, you have to write a function again to return the size of the item. Okay, so I'm passing the index number, set the new item to that slot. And then when you get it back, it looks very similar. The getter will look very similar to that one. I need to include the index name. a number. So down here, when I do a get public, the item is a string, right? So it's a get item. I'm getting the item at the index position. So I'm going to return this the items at that position. So now I can return the item back as long as I know the index. If you want to use the name instead, you can write a function for that as well. But now, just say I got that one there. I want to write the item for the first lot. Just say get item, and I need to provide the index, which is the first item. Okay, so now I got my first item, and when you run it, you should get the word sword, right? So you track your items this way, and later on, if you find a better item, if you want to swap out one of these, well, you have to replace one of these with a new item, and then you can keep that one and then toss the other one. So that's how you keep track of data in your bag or in your chest. And when you write games, you probably play this all the time. You want to increase your bag size, then you have to pay some money, right? Or you have enough gold and you can increase the size. When that happens, then you will create a new array. Or if you use an array list, then you can just increase the array. Instead of 5, you can increase it to, if you buy it, increase it to 10 or whatever the number is, right? So that's how it's done in games. You buy more slots in the game, and that's how they make money. Okay. So I track one item here, one type. I can track another type here, and so on. So like, items could be weapons. I call items, but it could be weapons. It could be your armor, shields, anything you can think of. So you can have an array of things you can track. And how do you get those is, again, by using functions, getters and setters, like I showed you here. Okay, here I'm showing you here, I'm only set one item at a time. Okay, what if I want to set the whole set at once? What if I find 5 items and I want to add them all at once? All right, you could do that too. And that is actually, it's easier in the code here because all you do is basically, you can do something like this. So public void, again, set item. This time you're going to pass a string of items. It's an array of items. It's a complete list. So you can say this items equals the items passed to it. Right? I'm passing an array instead of an individual item. So I can choose one at a time or the whole set. Okay? Replacing the whole set versus a single item. And you use this one here when over here, let's just say that you find a set of items. So over here you have to have something like this, string of items equals, and you can have like the first one is it's a knife, second is a hammer, third is a sword, it's a gun, and then you have one more for a lasso, for example. So I have 5 items, and then I can just set them. So I can say p1.setItem. Now I have 2 options. There are 2 options here. One is one at a time, or I can pass the whole thing to it. So I can set items. So now my slot is filled, completely filled. I can get the first item here. I can print the second item, third, fourth, and fifth. So they're all set already inside the whole list. Okay? So now when you run it, you get everything out of that list. So all my stuff are here, stored in that list one time. And you can still, because you have the function to set one item at a time, you can still override these. Okay? So again, that is something that you can do as a programmer to provide all these different functionality in your code. Okay, one, you can set all of them. You can set only one at a time. Same thing with the get item, right? So here I'm getting one back only. You could get the whole list back as well. Right? It will look very similar. So public string, I'm getting an array of items. So I don't care about the index because I'm going to get everything, right? So this items return the whole list. So now I got the whole list returned, all 5 of them, instead of just one particular item. And you use that when over here in your code, if you want to check what's in the item. So you can say something like string, it has to be an array, it has to match the array type, okay? It has to match the type. String is the temp items equals p1.getItem. And I call the one that takes no parameter, right? Again, back to that polymorphism. I'm not taking any particular item. This one takes one item at a time. This one gets everything, but it's assigned that to an array of items. And then from here, I can go through each item through the index. Right? So that I can check how many items I have in here. I can get the size, the quantity I have in there, and then pick a particular one. If I want to know what, if I have a sword or a gun or a lasso in there, I can check it. So I can say, if I have a lasso, then print it, otherwise ignore it, right? So then that's how you can use here. So you can say, if temp items of I is equal to lasso, then use it, otherwise don't. And what you do is now you have to loop through the whole list. So back to the loop, right? You looped before. Say for int I from 0, I less than the temp item style length. Remember all that stuff? I plus plus. You loop through the whole list and see if you find an item called lasso. If you do have it, and then console write, say, found it, or use it, right? Use it to attack, otherwise you don't have it. And then when you run this, you should see it says found it on the very top here. If it's not there, then you don't have the weapon, and you can't use it.